In the previous video, we saw what I would call the base function graphs for sine and cosine. In other words, it was just plain old vanilla sine x and plain old vanilla cos x. In this video, we're going to apply some transformations to the base graph to create new functions, and what does that impact have on their graphs. The only two transformations we need to consider this year is what happens if we put a value in for a here, and what happens if we put a value in for n here. And I'm going to focus on the sine function, but only because the cosine function is pretty much the same. It's just that the graph starts at a different position. They're both the same sort of shape, right? So let me scroll out and I'll show you two new words. Well, one new word really, and that is amplitude. So whatever the value of A is, it's the amplitude. Whatever the value n is complicated. So let's go to our Desmos graphs and I'll tease that out. As I have mentioned to you before, if you're going to multiply a function by a value, that's going to have a dilation effect. Now, this is a dilation of the output because the base function is sine of x. Don't worry about what that says, but it's sine of. So when we multiply sine by a value, it's going to impact each output value. So it's going to have a stretch effect or a shrink effect. Because we're multiplying the output, the function sine of x, by this value, the stretch is going to be vertical. Let's have a look at this in a bit more detail here. In the base sine graph, as mentioned last video, it goes up to but never goes past 1 and then goes down to 0 and then down to -1. So in the base graph, the amplitude of the function is 1. Amplitude is the height from the center of the graph, which for this year is always the x-axis, up to the tippy top of the graph. That's a length of 1. If we go over here and go down to -1, yes, it's -1, but the length is still 1. And so in the base graph, the amplitude is 1. What happens if I make a equal to 2? How does that affect the amplitude? There we go. Every single value along here has been stretched, has been doubled. And that means that the maximum, which was at 1, is now at 2. And the minimum, which was at -1, is now -2. So the amplitude is in fact the distance of from the x-axis to the minimum or the x-axis to the maximum. It is in fact the value of a, like so. So we can say that a is equal to the amplitude. It's the value of the amplitude. There is something slightly nuanced I need to add to that in a second, but at the moment, let's just take that as granted, that the amplitude is equal to a. What about n? N, I'll leave it at a equals 2 because it looks a bit bigger. When we change n, we are changing the input, and a change of the input will be a dilation that goes this way, so parallel to the x-axis. When I increase n, let's have a look at what happens. I'll make n equal to 2. What's happened is that instead of the graph cycling through over 2 pi, it's cycling through over pi. So by making n equal to 2, I have shrunk the graph. That's because I'm moving through the values twice as fast. So we're getting through the values twice as quickly, which means that by the time we get to pi, half the distance, we've already started to repeat. So it's moving faster. Okay, if I make n equal to a half, we're going to have the opposite effect. By making n equal to half, I'm effectively slowing down the inputs, which means that it's taking me twice as long just to make a single cycle. So our cycle is now 4 pi instead of 2 pi. Now, I've been using the word cycle a lot, but it's not the official word that we use. And if we look down at slide 7 here, I'll give you a little bit of language here. We call it the period. It's the length the graph takes in order to complete one cycle. For sine and cosine, the base period is 2 pi. Okay? I think that should make sense. If I make n equal to 1, that's the base graph. The graph starts repeating when it gets to 2 pi, and then it repeats again to 4 pi. Now, when I say the period is 2 pi, it's kind of because when I go from 0, I can see it repeats at 2 pi, but I don't have to start from 0. If I start from this peak here and then go to this peak here, there's a length of 2 pi across. Or if I start here and go to there, that's a length of 2 pi across. So any point and its neighboring point on the next cycle will have a length of 2 pi between them on the x-axis. Okay, so back to our notes. What does that mean in general? Well, for sine of nx and the cos of nx, as we just saw, the period is either increased or decreased depending on the value of n. So the period ends up being 2 pi divided by n. So I'll leave it with this example here. If I let n equal 2, we're going through the values faster, so it's a shorter period, and 2 pi divided by 2 is equal to pi. And we can see that's repeated here. We've got one cycle to pi, and the next cycle is 2 pi, then the next cycle is 3 pi. So each of these is pi in length. And that's what the value of n does to our function. It changes the period.